everybody. Wow, what a year it's been. Um, we've managed to find our way from extreme drought to winter in 3 weeks to some of the most productive cold storms on record, including putting snow in a lot of places people weren't ready for or able to deal with, creating its own emergency. And then stopping there, discovering just how much water we can push out of some of those foothill tributaries. Just a quick example there in early March. For those of you who know the Kings River watershed in Mill Creek, reached a peak flow of over 11,000 cubic feet per second, all by itself, without the rest of the Kings River from Pine Flat contributing anything. Just for perspective, that's more flow than fits through the lower Tuolumne River going through Modesto. So, needless to say, lots of activities to do. Now, had I done this all in a coherent presentation, that would have been awesome. Instead, you're going to get pieces of 4 presentations. So hopefully this doesn't get you too mixed up. But anyway, let's start with building a water year. How do we start? Well, we start with precipitation onset, those temperature anomalies, those of you that remember back to Labor Day, and one of the more fantastic heat waves to have impacted California. Setting the stage, getting a little bit of precip there before snowpack set in, and then winter, wet or dry, and notable anomalies. I say wet or dry when it turns out it can be wet and dry. And the notable anomalies both in the extreme dry and the extreme wet, and how they work together to give you an overall seasonal situation. Then spring, late season bailout or early shutoff. Well, what about a late season pile on, which we had this year, which turns out, though, peak snowpack timing right around the 1st of April. Hit climatological average, getting that spring temperature being cooler than average, pacing that melt just about as friendly as it could have been. Yet to come, summer. What happens as we dry down, build up that fire risk, work through the heat events in July, August, and September, and any tropical activity. With climate change, we always like to throw in then the multi-year prediction. Well, what about next year? We know what happened this year. As you might well imagine, everybody's really excited about El Nino and all the fun that's creating, and looking ahead to get into what might happen next. And then with climate change, thinking about how much different the rest of this decade is going to be from the previous one, and what the next one after that's going to look like. And for those of you folks that like to work with your climate change, folks that do planning, they often talk about mid-century, end of century. Don't always quite get all the detail that we'd like here in state government. Anyway, what I've harped on, and boy, get to figure this out a little bit further, is, well, how do we do this? Well, if we increase our managed volume capability on the waterfront, we can maximize the benefit, minimize the hazard of each event, work our way through the water year event by event. And we do that by partnering with our research community that help us better understand the state of the watersheds, how productive they're going to be, and how that changes now in a warmer world. It's not just everything quiets down for the wintertime and it's all runoff. It's much more active and dynamic warming and drying. So how do you know the state of the watershed, how productive it's going to be? Forecasts give you a lead time to figure out what to do with how much water that's going to come there. And then great technical work, but if you don't digest it in something that the managers and operators can use, it's just a cool science project. So really trying to get all that fit together. And then the underlying question, how does temperature fit into all this? Because it's really nuanced. And going to take a bit of explanation, but it does take communication and understanding how that warming world really is changing things. So those of you that like products, this is something really trying to get into an operational state, but I really liked what Christian Gerges did down at Scripps, doing this for statewide as well as different regions, really looking at how maximum temperature fluctuate over the course of a year, And when you hit the extreme heat in the top 5% of the historical record for that day, and those times where you actually hit the edge of the distribution there, both in the warm and the cold. So we find that the years that we're going through are a mixture of warm and cold events, and really understanding how they play, when they play. When you get those cold bursts, that can be really impactful, particularly in those ag communities that really don't like frost damage at critical times. So this is kind of a cool product, really built out of that heat wave around Labor Day, but really trying to turn it into something that I can put in an operational framework and put up on the California Water Watch. So kind of excited about that. Okay, let's stop that fun. Move on to the next one. I know, like I said, this is going to be a wild ride. Here we are. All right, so in the middle of all this adventures where I was at the State Operations Center, and for those that don't know about emergency operations, we have the Flood Operations Center that the department runs. This is where we coordinate a lot of the immediate flood response, what's happening to my levee, what's happening with the forecast, what are the watches and warnings, and we work with the Weather Service there in a really, really fantastic partnership that unfortunately is under a bit of threat, as it may look out that the folks that operate leases of buildings have maybe decided that they would rather we not be co-located. So maybe not the best decision making in government going on right now. And hopefully this year was enough of an object lesson to keep them on point there. But one of the things I got to do in this grand adventure was be a frequent appearance in press briefings. So I got to meet the media on a regular basis, and so we would cover. Here, let's put it into show mode here so you can see the actual. A little bit of fun with the precipitable water from our microwave satellites, really getting a chance to picture those atmospheric rivers, and we do see where the satellites kind of go out and you lose the data. A bit of a challenge. Alrighty, so here on January 7th, we had an expectation that if we could get through to January 19th, we just might make it. At that point, Monday and Tuesday, the second of 5 atmospheric rivers. It's also the largest one in that collection. It turned out to be 9. Just reminding them, forecasts will evolve, impacts will evolve as well. So here you are. There's the 5 ARs that were the start, and in the end became 9. This is a graphic from our partners at the Center for Western Weather and Water Extremes, really helpful in communicating where along the West Coast atmospheric river conditions are expected, looking out through a full 16-day forecast. So trying to get beyond that bar, they're showing where we actually have precipitation forecast maps from the California Nevada River Forecast Center. Here those maps are really showing for these events. On the left, the past 7 days that we've gone through, where you're looking at, anywhere from 1 to 10 inches of precip, and then looking for the next 6, where get to do it all over again and again. And just to kind of give everybody a sense of where we ended up in that 3-week stretch from December 27th to January 19th, we essentially had winter. We had 46% of the statewide water year precip. On average, December, January, February gives us half our annual precip. We had 86% of a seasonal snowpack get deposited in those 3 weeks alone. Didn't count for everything that came afterward. So really quite an impressive 3-week window. Also had many floods and records, a lot of damage, and a lot to learn about how government programs, particularly in the flood world, interact and align with local communities and some of the challenges. And you may have read about the Pajaro region and a quarter-century effort to try and improve the levee conditions there, getting the agreement finally signed in October. Unfortunately, not quite enough time to prevent the notable problems with the levee coming to pass. But we did make a lot of use of this in pre-positioning resources, understanding where flooding was expected around the state, working with our state agency partners in CAL FIRE and the Swiftwater Rescue in National Guard with high water vehicles that could help with evacuations, and the Department of Conservation really looking where the landslide risk was. Pre-positioning resources helping emergency response be ready, minimize that response time. Really was fantastic and a lot of fun, to be honest with you, to be a part of and really highlight what research can do when you put it into operation. And very gratifying to have an administration official say, I get it now. So those are those moments that you're really happy. And then this was a really exciting piece of the puzzle that we're actually pivoting from a research concept into part of NOAA's operations as part of the winter response. And that's those hurricane hunters going out of Louisiana headed for California. We had 5 Air Force C-130 aircrafts and a NOAA G-4 actually doing offshore sampling of those atmospheric rivers, getting that information ingested into the initialization of the weather forecast models. And lo and behold, it improved the forecasts. So a lot of really exciting work and really looking to see where this goes next. But you see along the bottom the number of entities it takes to even take a concept and help it pivot from a research idea into operations. Not an easy thing to do, hence that one. All right, bear with me. We're getting through it. All righty, so now we get to spring. And lo and behold, when you have a creek pumping 11,000 cubic feet per second into the stream that already has water coming out of the Kings River, we find that we can actually put water onto the Tulare Lake bed. Problem? Tulare Lake bed is no longer just a lake bed. It is a productive agricultural region. Also a large community of Corcoran on the lake bottom that's protected by a levee. And so you, on the left, you see conditions in April 1, right as we're reaching peak snowpack. We already had a significant amount of water on the lake bed. And wondering what 400% of average snowpack does and how that's all going to fit. Well, interestingly enough, look at May 15th on the right there, and we see that this was one of the most intensive on-the-fly management operations, working with local, state, federal resources, working to see how much of that water could be diverted before it got there, either used for purposes immediately or look at those opportunities for managed aquifer recharge. So this became a great laboratory to take a bunch of things that were ideas and say, what can you pull, what can be done immediately, and what can be done now? Great chance to look at, evaluate, and figure out. The next time we hit a big extreme, how do we get ahead of it? So we're not reacting, and we can actually start when we get an awareness that we're in for a really interesting year. And so this was a briefing I gave with for the State Operations Center. All the state agencies would meet to discuss what's going on. Weather Service give a weather forecast. I would then give kind of a context of the climate and how we work towards peak melt. Happened kind of beginning to middle of June. Reminding them as that warm weather kicks in, it initiates the dry down, and the lower elevation regions, where there will still be snow in the high elevations, the lower elevations are going to pivot into a fire regime. So you don't get really a chance to breathe as much as you might like, and then we move towards that summer circulation, really start paying attention to how the southwest monsoon is going to develop, as well as the coastal marine layer, where we have a big part of the state's population that has experienced true June gloom, as we've had a very robust marine layer working off the coast there, and really understanding how all these pieces fit together and interact with the communities of California. The regional snow plots, and this is a good chance to remind people about observations. These are from the automated pillows. They were put in the early 80s. So for them, the biggest year is 82, 83, because they didn't see 52 or 69. So we don't have that as a comparison with this particular set of instrumentation, but we can see from 83 that in the northern part of the Sierra, we didn't get there. The northern part, normally the wettest part of the state, had a good year, but it wasn't quite the same year that they had down in the southern Sierra, where 83 looks like it took a break while this year just kept on going. And the Central Sierra there around Yosemite really hitting right around that 83 mark. So really interesting to really talk again about the diversity of conditions in California and really get to talk about this year being a mix of drought impacts persisting in the midst of record-setting flooding, and how, as a state agency, you get to start learning how to do those things together. It's not one or the other now. It's just a collection of extremes to really go through this. Again, heavy use of the California Nevada River Forecast Center. If you haven't been to their webpage, a lot of really fantastic information on there, including if you click on one of the dots, you get this map showing the past 5 days and the next 5 days. But if you scroll to the bottom, you get impacts information where you can actually see at different stages what's getting flooded. How does that impact that region? I will point out to you, if you look at the map on the left, how many dots are in the Tulare Lake bed region? That's the right answer. Nothing. To get a dot, you have to have the local community work with state and federal agencies to develop that impacts information, to develop that forecast point to enable that response to happen. When it's not there, all that has to be done on the fly as the emergency unfolds, which I think makes this year's response in that region all the more impressive of how much was stood up as quickly, how many relationships were built on the fly, and really where entities like the hub can help maybe foster some foundational relationships that make that aspect of things, when things do get a little more spicy, can be stood up quicker if there isn't the interest to have it as a standing and existing element for whatever reason. Some really neat temperature data from CNRFC, showing both what the forecast is expected and the departure from average. This was one of our few warm-up periods where we were 10 to 13 degrees above average. Most of the time we've been 10 degrees below average through most of the spring, so really kind of interesting how this year has played out. And with that, we can actually stop and see if there are any questions, and there's just a fantastic picture of that marine layer taking shape.
Thanks, Mike. I have a question or two, but I want to give other folks an opportunity if they have anything that they want to ask or follow up on.
I'll just chime in one more thing that I didn't actually get to tell you all about was the value of the Airborne Snow Observatory. I actually had spatially mapping the snowpack this year. We do it across 12 of the 18 watersheds. It's still not a full operational program, and we only do 4 flights a year. But this year we really would have liked a full suite of 8, but as you can imagine, that's a really expensive program. And you have to have a snow-free LiDAR baseline flight to be able to do the differential measurements. But the areas that we had it was absolutely fantastic, telling us not only how much snow was there, but with the associated modeling the state of the snowpack. So we could start telling people about how ripe a snowpack is and doing some education there, that just because it warms up doesn't mean the snow is instantly going to melt. Everything's going to come down the mountain all at once. That it takes time and energy for that snow to move from its crystal solid form into a liquid form, work its way through a deep pack into the streams and downstream. So anyway, really cool data, a lot of fun, hoping that generates interest in that program as we move forward. Anyway, Tapan.
Great presentation. I always learn a lot. I'm curious about El Nino, and there's a lot of talk about stronger one. Do you expect greater forecast skills for California?
No, so I just actually put together a briefing document on this and look at kind of what we expect with an anomaly around 1.5 degrees Celsius. And what does that get us? Well, it could get us to a year like 1987. It was a really lousy drought year. It could get us a year like 2016, right around average.
Yeah.
it can give us I can't remember the year that was a really big year. So it really, just the presence of El Nino doesn't tell much about California because there's so much else that comes into play. Now, doesn't mean we can't say there's nothing we can tell you, because there are some things that do happen. The one, the jet stream kind of flattens out. We've lived with La Nina, where we have that high pressure and the looping jet stream over the high pressure or under it. And with El Nino, it flattens out. So those storms are zipping across, and that jet's really juiced up. So you're going to see more wave action on the coast. So coastal erosion, cliff erosion, going to be a challenge. We tend to see higher sea levels. So we think about all the sea level rise we've seen in the past 10 years, and then realize we're going to do a little bit more than that. So it'd be interesting to see where the episodic nuisance flooding maybe takes another step and becomes a little more of an issue in the coastal flooding component. Figure out how we're going to react to that. And then we'll just have to look and see, hopefully as we get into fall, and get a little bit better understanding of how things are setting up, how to deal with the inland conditions. But it is really amazing that for both El Nino and La Nina events, we can literally span the distribution of our historical record.
Thanks, Mike.
Yeah, thanks, Mike. That's your response to the El Nino question is pretty interesting. I mean, I for one had always kind of been under the impression that for Southern California, at least, that El Nino had a bit more of a clear signal. So, but I suppose statewide, spanning the latitude that we do, that's not the case when you think about us as a whole. I'm gonna take the opportunity, unless anyone else really wants to jump in. I'm really curious about how DWR is thinking longer term towards the future. I mean, our understanding of climate change is that the state's going to be experiencing these sort of greater extremes, this sort of precipitation whiplash, as it has been dubbed. And so when we have these big years, what are we learning about water storage and water management? Did anything come out from this year that the state is thinking about? How can we apply this to a future where we might have more extreme years with a lot of water that we really need to hold on to for those super dry years? So from a climate change perspective, what are you guys thinking?
We actually met on this morning about how to take the lessons learned out of this year, where really did take advantage of the opportunity to say, hey, the planners keep talking about managed aquifer recharge. How quickly can we make that happen? What's missing? Do you need a pump? Let's create pumping, connect it to the irrigation districts. If you can get water out of the rivers, bring those levels down, love to have you put it into those fields that we know are good recharge zones. And then how does that set the stage for this managed aquifer, where the value of that field becomes managed aquifer recharge? And how does that relate then to how it also relates in the growing season? And how do you do that? So a lot of experimental work, if you might say, done this year. Really good chance for lessons learned. But we really talked about, this year we were very reactive, always kind of chasing things. Imagine what it looks like if we have this as our foundational perspective, that we head into the year expecting that we're going to be trying to take advantage of the lead time we have in forecasts to try and anticipate where we can position water as, so we can make the most use of it and not just have to dodge it all as a flood extreme. And really getting that best of keeping people out of harm's way, but also making the best use of water. And then what does that take, right? It takes a fantastic amount of coordination. It takes a really significant amount of collaboration across agencies. This is where things get a little trickier, because again, it gets to relationships that you build, and while you get that opportunity to build them under pressure during an extreme event, but how do you do it so that it becomes the baseline, that's your base relationship is how do we work together to solve this, and how does that then work to break down some of those policy barriers? weren't set up to be policy barriers. They just kind of turn out that the way the rule sets are create some rather significant challenges to getting some things done. So how do you work through it? Or is there a way to maybe refine it so that the intent of that policy is maintained, but it becomes more flexible to accommodate those opportunities to gain more benefit? So there's a lot to be dug through. That was the outcome today. There's a lot to dig through, but we're really interested in trying to be proactive rather than just wait for an emergency and scramble like I'll get out to see what we can do.
Great. Well, always good to hear that the state's talking about it. Thanks, Mike. Steve, any final comments before we let folks go?